So that's cool, that's nice, but what about this other word at the beginning of the note, something called multiplicity? Alright, so multiplicity is just a fancy way of asking how many times does a root or solution appear in the polynomial. And yes, they can appear more than once. How the heck can you tell that, though? Interesting. So, one way to tell it is factoring. Factoring never goes away, so if I have a factor of x minus c to the n, it is a factor, then c is a root of our function with a multiplicity of n. So n is always going to be how many times it appears in the polynomial. So problem 4 says, please find the roots of the polynomial and list their multiplicities. So the first thing we got to do is factor this. Well, first thing I look for when I factor is a greatest common factor. For the love of everything, please look for a GCF first. So I should find that x goes into both of those, and then I get x squared left over minus 36. And then we should recognize this as a difference of squares. So factoring that further, I should get x plus 6, x minus 6, and I still have that x out in front. So my factored form should be that, meaning that my roots are 0, negative 6, just solving for x, and 6, just coming from those factors. Alright, and multiplicities, this has a multiplicity of 1, this has a multiplicity of 1, and this has a multiplicity of 1. Cool. Alright, next one's a little bit harder to factor. So, hold on. Alright, so I'm going to be honest. I used my graph and found out that my roots are 1, negative 5, and 11. AKA my x-intercepts. Okay. Which means that my factors, going backwards, I should have said x is equal to 1. So that means that x minus 1 was equal to 0, which would be my factor. Because we always set our factors equal to 0. So I would have x minus 1. If x is equal to negative 5, that means x plus 5 was equal to 0, which would have been my factor. And then I have x minus 11 as my factor. Alright, again, my multiplicities. This only has an exponent of 1, this one has an exponent of 1, and this one has an exponent of 1. So my multiplicities should be 1, 1, 1. Alright, looking at C, I see that it's already factored for me. So my roots or my solutions should be 1 and 7. Alright, and then my multiplicity, well, when x is equal to 4, it has a multiplicity of 2. And then when x is equal to 7, it has a multiplicity of 4. So respectively. Alright, next few, let's go look at a graph. Fun times. Alright, so the next thing I'm going to do is take a look at some graphs and let's see how they compare. So this graph should be that x plus 6 squared times the quantity of x minus 7 squared. So going and seeing how my factors relate to my x-intercepts. Again, they are related. So I see that I've got an x-intercept at x equals negative 6 because solutions are when I actually set that factor equal to 0. And my other one's over here at 7. So a couple things to notice is that that x plus 6 squared is a positive degree, which will be important here in a second, and that x minus 7 has a multiplicity of 1, which is an odd degree. Alright, and then looking at the next graph below, I've got the x plus 6 quantity squared. So again, looking at my x-intercepts, when I set x equal to 0, I'd have to solve for x. So I would get x is equal to negative 6 and x is equal to positive 7. Alright, again, looking kind of how the even degree might affect that graph, since there's a multiplicity of 2, is another way to say that now. Alright, what about the next couple graphs? Alright, now I've just got 2 odd degrees. So I've got an x is equal to negative 6 and an x is equal to positive 7. Alright, so the multiplicity is still there. And then what about this last one with the x's plus 6? So that means that I have a x-intercept at negative 6 and an x-intercept at positive 7. Alright, so what conclusions can we make about these drawings when it comes to multiplicities? Well, it's anytime that there's an odd degree or odd multiplicity, it's going to cross that x-axis. Versus if it's an even degree or even multiplicity, it's just going to touch the x-axis. And then just go right back. So when I had a multiplicity of 2 on that 7, it came down, it touched it, and then it got rejected. But when I had a multiplicity of 1, it actually crossed. That's all that's saying. Alright, so that's not bad. And can I tell anything else? Yeah, we can tell how many possible turning points that we have. So if we have a polynomial that's to the degree n, we have at most n minus 1 local extrema, which is kind of what I was talking about way back here when I'm like, okay, it could look something like this, it might look something like that, or it could look something like that. We don't know unless we chart it out. Alright, and like I said, we'd get to that later. Now is apparently later. So, yeah. Alright. So all that means is if I have, for example, x to the 5th, then I could have 4 turning points. And then we'll learn later that after we subtract 1, it's just going to go down by 2 every time. So I could have 4 turning points, I could have 2 turning points, or I could have no turning points at all. Subtracting 2 every time. I can't have negative amount of turning points because that would just be weird. It's either going to turn or it's not. Alright, see you in my next video for the graphs.